Hi, welcome back to this week's video from Mr. Talbot Maths. This week what we're going over, as you can see on the screen, is indices. It's the topic for today. So, a few questions I've got on the board there, which you might be wondering if you're not sure about indices, or if this is a new topic to you, you might be thinking, or might have crossed your mind at some point. If this isn't a new topic to you, then you probably won't know the answers to these questions, but I'm going to be going over everything to do with and related to indices during this video. And as always, if this is useful, if you like the video, make sure to like and make sure to subscribe. Right, so first question really, what are index laws? That's the first thing I'm going to be covering. And then fractional indices, can you have them? Because with some things like ratios, we don't tend to use fractions. You tend to write them as integers, whole numbers, don't you? And then can you have negative indices? Is that a thing? Okay, so we're going to look at them and we're going to see if they do exist, where they come from and why they are what they are. Okay, right, so without further ado, let's get started. Okay, so first thing to get started with is the laws, and basically that's how do these things work. And before I go through that, I just want to explain very quickly for those people that might not know what an index or an indice is. So an indice or an index is basically a power. So when you have something like 2 squared, this bit up here, squared bit is the power, the index. Okay, means the same thing. Or you might have heard the term order if you have used BODMAS before. Brackets, order, division, multiplication, addition, subtraction. Or BIDMAS for indices. So they're the same thing, and it's the power that something's raised to. So, and really what that means in mathematical terms, if I have 3 squared, that means I've got 2 3's times together. So 3 times 3 gives me 9. Okay, so that's what the order is. It's how many of that number is multiplied together. And one of the misconceptions is, oh, well, you just double it. Well, 3 squared isn't double 3, because you don't times it by 2, you times it by 3, because there's 2 3's. So that's how they work. That's what the indices are. And there's a few things we need to know and, well, learn about these. So index laws, where do these come from? So they come from, if I had something like 2 squared times by 2 cubed. And people thought, well, is there a quicker way of working this out? Especially with big powers, big indices. Okay, so if we think about what this would be, well, 2 squared is 2 times 2. Okay, that's 2 squared. Okay, and then we've got that times by 2 times 2 times 2, which is 2 cubed. Okay, now what that gives us is, well, how many 2's have we got? We've got 1, 2, 3, 4, 5. So if I've got 5 2's multiplied together, that's got to be 2 to the power of 5. And so then we see that actually when you multiply, we add the powers together. And that's why this law works. You might be told this law at some point, but you might not actually understand why it works. And I think it's a lot more helpful if you know why these laws work. It's a lot more helpful to remembering these things. So yeah, it's because powers, the indices, are all to do with multiplication. And obviously, if we multiply together, we've got more of those, or more of that number or thing, if you're speaking about algebra, multiplied together. So your powers are going to be added. Now, division, we'll see how that works. So if I go with 2 to the power of, let's go with something relatively easy to write down, 2 to the power of 4, divided by 2, I'm just going to put 2. Now, if I just leave it as 2, what's the power? What do we use? Well, the power is 1, because I've got 1, 2 there. Okay. So I've got 4 2's divided by 1, 2. So 4 2's, 2 times 2 times 2 times 2, divided by, and you can use the fraction symbol as division, so divided by a 2. Okay. Now, if I've got this, one of the 2's on the top will cancel out with the divide by 2 on the bottom, so I'm going to end up getting rid of one of my 2's, and that would leave me with 1 on the bottom, not 0. okay? Because essentially what I've done there is divide by 2, top and bottom, okay? So I'd end up with 1 on the bottom, 2 times 2 times 2, well, divided by 1, that's the same as 2 cubed. And so we can see from here that it's kind of the opposite, or inverse if you like, of the multiplication rule. So multiplication rule, you add your powers to get the power of your answer. And division rule, you subtract your powers. 4 take away 1 gives me 3. Okay, so if you divide, you subtract your powers. Now, the final one is where we've got something like this. I'm going to choose a different base this time. Base means the big number, okay? So I'm going to go with 3. I'm going to go with 3 squared. Now I want to do 3 squared, and I'm going to cube it. So I want 3 of the 3 squareds times together. So I'll write that out so it makes a bit more sense. So I want 3 squared times by 3 squared times by 3 squared, because that's 3 squared cubed. Okay, that makes sense. Now, I've got multiplication here, and I learned this rule at the start. With multiplication, I add the powers. So my base is going to stay the same. I'm still going to get base 3. 2, add 2, because it's multiplication. Add 2 again. Well, that's 6. Okay, so what could be the rule here? Well, actually, to get a power of 6, I've multiplied the powers inside and outside the brackets here. So 2 times 3 gives you the 6. So, I'll say that one more time. I'll go through what we've done there. If you multiply with the same base, then you add your powers. If you divide with the same base, in this case 2, then you subtract your powers. And if you've got a power of a number, and then brackets, and then another power outside, then you need to multiply those 2 powers, because you're basically doing the thing inside the bracket, so that original number, the base with the power, and you're multiplying it together. However many times is outside of the bracket, how many times that power is. Okay, so brackets, you multiply your powers, divide, you subtract them, times, you add your powers together. Okay. Right, so they're all your index laws, and there's one extra thing I just want to go through here, just while I remember, and that's to do with division, really. So if I have, and this links into the next bit actually, if I have 2 squared, I don't know why I keep going with 2, it's just a nice easy number to work with, I suppose, isn't it? Divided by 2 squared, then I know that with division I subtract my powers, so I'm going to end up with 2 to the power of 0. Right, okay, so that's going to be 2 to the power of 0. I've got to think of, let me think of another way of writing this. Well, that's 2 times 2 over 2 times 2. And just like before, the 2 on the top will cancel with the 2 on the bottom, and the 2 on the top will cancel with the 2 on the bottom. Now, it doesn't leave 0, don't think it does, it doesn't. It's going to leave 1 on the top divided by 1 on the bottom, or 1 divided by 1 is 1. Okay, that seems fairly obvious, I should think. So anything to the power of 0 is going to give us an answer of 1, which I think is really interesting. So anything 5 billion to the power of 0 is 1. And I think, well, there's a massive number called a Google, isn't there? I'm pretty sure, like about 100 plus zeros. It's got a ridiculous amount of zeros. Well, that to the power of 0 would still be 1. Okay. So to me, that's kind of a mind-blowing thought, that you could pick any number and it would still be 1. Now, the next thing to look at, and links in very nicely to that last bit, is the negative powers, negative indices. Can you have those? Well, I'm going to use a similar principle. I'm going to use division. I'm going to choose some different bases this time because it's getting a bit boring, the 2's, isn't it? But let's go with 5 squared, and I want to divide that by 5 cubed, because now my division rule tells me I subtract my powers, so that's going to give me 5 to the power of negative 1. Now what I want to do, and this is exactly the same kind of procedure as the 2 to the power of 0 that we just looked at. If I have 5 squared, that's 5 times 5, divided by 5 times 5 times 5. Okay, so we've got something like this. Now again, the 5 on the top will cancel the 5 on the bottom, and the 5 on the top will cancel the 5 on the bottom. So that's going to leave me with 1 on the top and a 5 on the bottom. So 5 to the power of negative 1 has to be equal to 1/5. And we'll find that any number, so 6 to the power of negative 1, is what's called the reciprocal. It's basically, well, it's what we would times the original number by to get 1, but also it looks like it's kind of flipped or made into a fraction. And this works with any number, so 243 to the negative 1 is 1 over 243. Okay? Now, it gets a little bit more interesting than that because that's just the negative 1 part. So what about if we had negative 2? And we can figure that out because we can make a power of negative 2. So let's do that. I'm going to use exactly the same principle. So what I'm going to do is I'm going to use, again, a different base. It'll be good practice this with square numbers and cube numbers. And actually, to be really proficient, to be really good with the index laws, with using indices, we need to have a really secure understanding of square and cube numbers. That's going to be really beneficial. Okay, so let's try 6 to the power of 1, or just 6, divided by 6 cubed. Okay, now using the index laws again, that's going to give me 1 take away 3, which is negative 2. So again, it's not negative 1, but let's see what happens here when we decrease the power. So I'm going to get 6 on the top divided by 6 times 6 times 6. Now again, we can cancel out, so 6 on the top will cancel with 6 on the bottom, and that leaves me with 1 over 6 times 6. Now interestingly, that's 1 over 6 squared. Okay, so 6 to the negative 2 is the same as 1 over 6 squared, and 1 over 6 squared is 1 over 36. Okay, so the negative power will, to get rid of that, you make the number into the reciprocal. Okay, so if it's a whole number, it's 1 over that number. And then this power here, so the number, the value, if you like, the absolute value it might be called. So this number here, once you've got rid of the negative, you then need to do that power. So we need to square 1. 1 squared is 1. 6 squared is 36. So let me give us another example. If we had something like 4 to the negative 3, well, that would be 1 over 4 cubed. And, well, 1 cubed is 1. 4 cubed, well, 4 times 4 is 16. And times that by 4 again, we get 64. Okay? Right. Now, that's all well and good, and that's very useful. But what about then if we have fractions? So I'm just going to delete this bottom part here. So get rid of this. What if I had a fraction with a negative power? Because at the minute I've only had integers, I've only had whole numbers. So we're going to change it so it's fractions. So what if I had 2/3, okay, to the power of negative 2? Now the negative part, like we said before, that does the reciprocal. And, well, the definition of reciprocal is what would I times that number by to get an answer of 1? Okay, so what would I times 2/3 by to get an answer of 1? And if you've learned about reciprocals, we should know that that's going to be 3 over 2. But now I still have to square this. Now 3 over 2 squared is 3 over 2 times by 3 over 2. 3 times 3 is 9. 2 times 2 is 4. So that would be 2/3 to the power of negative 2. Okay. So that's how it works with negative powers. And obviously as I increase, or decrease I should say, negative 2 to negative 3, I would do the reciprocal and then I would cube it, and so on. Okay? Right. Now the final thing to have a look at is about fractional indices. And where do these come from and do they exist, first of all? Now, they do exist. And what we can do to think about this is, okay, I know my index laws tell me that if I have 2 to the power of 1 times 2 to the power of 1, that would give me 2 to the power of 2 squared, because you add your powers. Okay, now, if I had as my answer 2 to the power of 1, okay, I want to, well actually, before I get to this bit, before I get to this answer, let's think about, let's imagine that fractions can work, okay, and try and figure out what they would be. So if I had 2 to the power of a half times by 2 to the power of a half. Now we know what that would give us. That would give us 2 to the power of 1, or 2. Now, this, using our index laws, gives us 2 to the power of 1, but another way of writing it is 2 to the power of a half squared. That's got to be equal to 2. Okay? So, something, this number, that we don't know what it is, 2 to the power of a half, we don't know what that is. Okay, but if we square it, we get 2. So something squared gives me 2. Now what could you square to give you 2? Now the only thing you could square to give you 2 is the square root of 2. Now I don't know what that is, but it doesn't really matter. It's going to be some decimal. I mean, I do know some of the decimal parts of it, the early parts of the decimal notation, but that doesn't really matter. All I need to know is that it's the square root of 2, because the square root of 2 squared is equal to 2. So that means that 2 to the power of a half has to be equal to the square root of 2, whatever that is. Okay? So that's what the fractional indices are. Now, I'm going to clear all this out of the way. And we're going to have a look at some other fractional indices. Because obviously, it's not just going to be power of a half. What would a power of a third be? What would a power of 2/3 be? What would things like that be? So, we're going to have a look at things like that. We'll leave this at the top. Now, you can have a very good guess at what 2 to the power of a third might be. Now, I would need 3 2 to the power of a third to add up the indices to get 2, or 2 to the power of 1. Okay, so that means I need 2 to the power of a third cubed to get 2. So that means that 2 to the power of a third must be the cube root of 2. And then we've got something else there which is very useful. So we've now got power of a half, we've got power of a third. What about power of 2/3? Well, that's, again, using your index laws. So again, I'll bring this up to the top so we can leave that there. Okay, so we've got 2 to the power of a half, 2 to the power of a third. Okay, now, the next thing is, what would 2 to the power of 2/3 be? Now, these rules work with any base, so I'm just using 2, but any number is the same rules apply. So 2 to the power of 2/3. Now we need to think quite creatively again about how we can write this, and we can write this as 2 to the power of a third. Now when do I multiply my powers? Well, I multiply them when I have the brackets. So 2 to the power of a third squared. Okay, now I can rewrite 2 to the power of a third, that's the cube root of 2. So I've got the cube root of 2 squared. Okay. Now that's not particularly useful with 2 to the power of 2/3 because we can't actually work this out. But we might get questions where we have something like 16 to the power of 3/2. Okay? And we have to work this out. So we'd rewrite this as this denominator tells us what root to do. So because of 2, we do square root of 16. And then when we get the answer, we do the numerator, we cube it. Okay? So I can do the square root of 16, that's 4. And then I cube it. And what's 4 cubed? Well, 4 times 4 is 16. And 16 times 4 is 64. And so that's how we get the answer. Okay. Now we'll do one more of those, and I'm going to put in a negative as well, because it's always quite useful to look at the negatives. Okay. I'm going to leave that example by the top, again, just for reference. So we'll leave that up there. Now, what if we had something like, let's go with 36 over 25, and I'm going to do that to the power of negative, let's go with, I want to go with 3 over 2 again. So negative 3 over 2. Okay. Right. Now, the negative part is going to mean we do the reciprocal of the fraction, so we flip the fraction. So 25 over 36. And then we're going to do all of that to the power of 3 over 2. So next thing we're going to do is we're going to square root that fraction. So square root 25 over 36. And then, once we've done that, we're going to cube it. We're going to cube everything. So, square root of 25 is 5 over 6. And then we're going to cube it. 5 cubed is 125. And 6 cubed, well, 6 times 6 is 36. And then you might have to do some working out for the next bit. But 36 times 6 is going to give us 216. And if you don't believe me, we can check. So 36 times 6. 6 times 6 is 36. Carry on 3. 6 times 3 is 18. Add the 3 is 21. 216. Don't be afraid of working out these if you need to. You know, you're not always going to remember all of them, and it's absolutely fine to check. So that would be our answer. Okay, so that's a quick run through. I say quick, it's taken 20 minutes, a lot longer than I expected really, but that's a brief and quick run through of index laws, negative indices, fractional indices. Okay, I hope that was useful. I hope that's clarified any questions that you might have had at the start, or generally about this topic. If you've got any other questions, please put them in the comments below, and I'll make sure to get back to them and answer you in the comments. And as I said at the start, if this was useful, if you want me to do other videos, put it down in the comments, because it tells me that actually this has been useful, and please subscribe to my channel. Okay, thank you, and I'll see you next week. Bye-bye.